The seven bridges of Konigsberg problem caught the attention of a famous mathematician by the name of Leonhard Euler. In 1736, Euler finally proved that it wasn't possible to cross each bridge exactly once. He was able to do this by simplifying the problem. He realized it didn't matter what path you took on land, the only important part was where each bridge was connected. Euler simplified the landmasses into what he called nodes and turned the bridges into simple lines that connected them. So he turned the seven-bridge problem from something that looked like this into something that looked like this. The resulting image is a mathematical structure called a graph, although not the same type of graphs that you were used to. Next, Euler realized that if you went to a location, you would also have to leave that location. So every location would need to have an even number of paths. The only exception to this would be the start and end paths, which could have an odd number, since you didn't have to go to the start or leave the end. In simple language, the possibility to walk any path exactly once depends on a number of paths or degree of each node. If there are either two nodes or no nodes that have an odd number of paths, then it is possible to walk the paths exactly once. Further, if there are two nodes with an odd number of paths, then one of those must be the start and the other must be the end. However, all four of the land masses in the original problem are touched by an odd number of bridges. One is touched by 5 bridges, and each of the other 3 is touched by 3. Since at most, only 2 of the land masses can have an odd number of paths to serve as the endpoints of the walk, there is no way that we can walk all 7 bridges only once.